Okay, Algebra 2 students, this is your Unit 1 review, and we are now on page 3. We are writing equations in slope-intercept form, and this time we are not given the m or the b. So let's start by finding our slope. The slope is going to be the second y minus the first y over the second x minus the first x. So I get negative 2 over negative 4, and the negatives cancel, and 2 over 4 simplifies to 1/2. And then we need to substitute into y equals mx plus b. And you can use either point. So I'm going to use the first point, and this is my x, and this is my y. We need to find the b. So I put 5 for the y, and 1/2 for the m, and 1 for the x. Oops, plus b. 1/2 times 1 is 1/2, so I have 5 equals 1/2 plus b. And then I need to subtract 1/2 from both sides. Okay, so 5 minus 1/2 is 4.5, but if we want to have that as an improper fraction, I can change my 5 to be 10 over 2, so I have a common denominator. So I'm thinking 10 over 2 minus 1/2 equals 9/2, and that's going to be my b value. So these cancel out, and I get 9/2 equals b. So then if I'm writing y equals mx plus b again, now I know my m, I found it with the slope formula, is 1/2, and my b is 9/2. Okay, in 18 we're going to do the same thing. We're going to start by finding the m. So 6 minus negative 4 is the same as 6 plus 4. And 1 minus negative 4 is the same as 1 plus 4. So I get 10 over 5, which is 2. And again, I can use either point. I'm going to choose the one with positive values. So I'm going to choose this one. But it's okay if you choose this one, you'll get the same answer. I have y equals mx plus b. My y is 6, my m is 2, and my x is 1. So 6 equals 2 plus b, and then subtract the 2 from both sides to get 4. So y equals mx plus b, my slope is 2, I found it here, and my b is 4. Okay, moving on to absolute value equations. Now I know you don't have a graph over here, but I just put that right there because I'm going to show you a second way to solve this. But let's go to the algebraic method first. In the algebraic method, you want to start with the general form of the absolute value function, which is y equals a, absolute value, x minus h, and then plus k. And when you're looking at this general form, your vertex, the x-coordinate of the vertex is your h value, and the y-coordinate of your vertex is your k value. So if we plug these in, the only thing that we're going to be missing is the a. We can use 0 for h, we can use 4 for k, and then over here we have another point, so we can use those for x and for y, and we can solve to find out what a is. So we said y is going to be negative 2. We don't know a. X is 3 minus the h, which is 0, and plus k, so plus 4. Okay, 3 minus 0 is 3, and absolute value of 3 is 3, so I have negative 2 equals a times 3 plus 4. To get a by itself, we'll subtract the 4. So I have negative 6 equals 3a, and then I need to take that over here. Negative 6 equals 3a. Divide by 3, and a equals negative 2. So now that I have the a value and I was already given h and k, I can write my equation. So y equals, then comes the a, negative 2, absolute value, x minus h. So x minus 0 is just x. And then plus k, and my k value is 4. So this is your equation, and I found it algebraically. I could also find it graphically. So if you don't like this approach, here's another one. I have the vertex at 0, 4. Now I know you don't have this grid, so you can draw yourself a grid or use some graph paper. So 0, 4, this is my vertex. And then I have another point at 3, negative 2. Okay, so my V shape will look like this, and because it's going to be symmetric, I'll have another point over here, and it'll go like that. Okay, so I can see that my vertex moved up 4, and that's how I accomplished this plus 4 here. It did not move left or right, so I'm not going to have a plus or a minus inside my absolute value. It did flip upside down, and that's what produces the negative here. And then I can see that it was stretched. I can see the stretch because instead of going down 1 and over 1, it goes down 2 and over 1. So from this graph, I can see again that my equation is y equals, to get the flip, I need a negative. To get the stretch that's down 2 and over 1, I need a 2. Absolute value. My vertex did not move left or right, so there's no plus or minus on my absolute value inside the absolute value. But I did move up, so to move this up 4, I need a plus 4. So notice, it's the same equation whether you approach it algebraically or graphically. Okay, in 20, we're going to look at our equation. If you have x plus 4 inside the absolute value, that moves your vertex from 0, 0, it moves it left 4. Remember, if it's in the absolute value, it goes opposite of the way you might think. So if you think the plus 4 would go right, it's actually going left. Your vertex also moves down 2. So from 0, 0, I need to go left 4, 1, 2, 3, 4, and down 2, and this is my new vertex. Now normally from this vertex, your V shape would go over 1 and up 1 on each side, over 1 and up 1. But we have a stretch of 3, and 3 is the same as 3 over 1. So when I go up 3, I go over 1. This is my stretch of 3. Up 3 and over 1, and do that on both sides. Okay, and then you want to use a straight edge to make a nice line. Okay, hopefully your lines are better than mine. So the vertex, that's what we found when we moved left 4 and down 2. It is going to be the opposite of this number, so negative 4, and then this number, negative 2. The axis of symmetry is the line that goes straight through the middle of this function. And basically, the graph is symmetric to your axis of symmetry, meaning that if you reflected it across the axis of symmetry, you would see the same exact graph. So it's right here in the middle. Because it's a vertical line, this is going to be an x equals line, always. And if you check it out, you can see the x's are always equal to 4 on this line. You can also, they're always equal to negative 4. You can also get this number from your vertex. So whatever the vertex x value is, your axis of symmetry is x equals that number, x equals negative 4. 2 additional points on your graph. Okay, we found those points when we were graphing our stretch. So from the vertex, we went up 3 and over 1. So this point right here has coordinates negative 3, 1. And then this point over here, we went up 3 and back 1, so that would be negative 5, 1. Of course, you could have chosen these points as well. There are a lot of choices for the points. Just make sure that you've graphed accurately, and then you can find 2 additional points. Horizontal shift is the left and right. So we shifted left 4. And then the vertical shift is the up and down. We shifted down 2. Is there a reflection? If there was a reflection, my A value would have been negative, this number. But there was no negative, and we did not flip our absolute value upside down, so there's no reflection. And to evaluate f of 2, you just want to substitute 2 into the equation. So it will be 3, absolute value. Instead of the x, I'm putting the 2 in, plus 4, minus 2. So you add that, we have 3 times the absolute value of 6. And the absolute value of 6 is 6, so I have 3 times 6 minus 2, 18 minus 2, which is 16. And that's the end of page 3. If you need help on page 4, please open the new video.